Roll tape.
Okay, you guys, I decided not to rename it. It's been what I've called it all along, Meteors 101. Go ahead. Talk a little bit about some things like what exactly are meteors, and I'd like to also talk a little bit about what they're not, how we can best see them, which way to look, and I always make the little joke here that Dennis O'Day is our great friend up in Memphis. He's famous for having said, if you want to see meteors, look in the direction I'm going and turn around and look in the opposite direction.
You're
So,
welcome.
That's one way to do it, but there are other ways, and we'll talk about it. What time of the night of the year or of the year is best, and where are the best places to go to see them? Obviously, dark places. Obviously, places with little trees, no street lights, stuff like that. Okay, Jane. What are meteors? Of course, many people know them as shooting or falling stars, but we now know that they have absolutely nothing to do with stars. They are actually small bits of rock and dust and metal that are traveling in space between the planets, which makes them, every one of them, E.T. the extraterrestrial. And the vast majority are caused by comets. There are a fairly significant batch that are caused by asteroids. And there's one great meteor shower coming up in December called the Geminids that's made by an object science doesn't know what the heck it is. Some people feel it might be a comet. Other people might be an asteroid. Some say it's a hybrid between a comet and an asteroid. It acts like a comet sometimes and acts like an asteroid at others. But whatever it is, it produces a spectacular meteor shower in December, and I pray we will get a chance to see it this year. Last year, wiped out from one end to the other by weather. They blaze into a flash of light through the Earth's atmosphere, collision with the Earth's atmosphere, in a process called ram pressure, not friction. Friction is when two solid objects are rubbing each other. This is a solid object coming into a gaseous medium, the atmosphere. So they call it ram pressure. And the thing that blows away most folks that are at our star parties and whatnot, most of the ones we see at night, half a second, about as bright as the rest of the stars, the particle size is no larger than a speck of dust or a grain of sand. Amazing. Classic image of a meteor. Because it's so classic, I didn't take it. But this reminds me of a picture that Robert Hirsch got a couple of years ago. You might have been there, Jane, Mary, you were probably, several of us were there. He had set up, it was the warm up to the Perseids. It was early August, wasn't even the maximum. Robert hooks his stuff up, gets it ready, starts to expose, goes to do something else, and says, Paul, will you kind of keep an eye on everything? And I look up, and the minute he walks away, a -2 Perseid flashes all the way down the length of the Milky Way. And he got it. This one is not, because it's going perpendicular to the Milky Way. But the one he got, right down the Milky Way. Oh my gosh, I was jealous of that before. It was an excellent photograph.
I remember that.
Remember that?
Yes, I do.
Okay. Confusing comets and meteors. This, a show of hands, did anybody in this room ever get to see Comet West back in 1976? Mark, did you got it? Excellent. Mary, you saw it? Comet West, you did? Excellent. That was 48 years ago, 1976. That is what it looked like. That's Comet West in March of 1976. It was life-changing, unbelievable. Unbelievable. There's no way I could describe it.
So is that magnified or is that real?
That's not even half of what it looked like to the eye.
Really?
It looked like a fountain spraying light over most of the eastern sky. The head the tail was visible for a solid hour before the head rose. I mean, you can't make this stuff up. Nothing, not even NEOWAS was even close. But NEOWAS was good. But when you talk about comets and meteors, a lot of folks seem to get the two mixed up. They think that the comet is the one that's flashing by in a full blaze of light and goes out after a split second. And they think the meteors are the ones that are up there for time. It's exactly the opposite. The comets are visible for weeks and or months, and even in some cases years, depending on their orbit. And the meteors are the ones that flash by in a split second of time. And that's, of course, because the meteors are pieces of the comet. The comet comes into the sun, gets close, heated by solar wind and energy. What did they call it? It was a dirty snowball. Comets were called dirty snowballs. And when they come into the sun, they get heated up, and all that dust and all that gas and all of those particles begin to flow behind the comet, pushed by the solar wind out from the sun. So that kind of clears up a little bit of the confusion that a lot of folks have, and we get a lot of that from our public outreaches and for new people at star parties. So we try to give a little bit of info on that to help them. But if any way we could turn the clock back to March of 1976 and see Comet West, I would love for everybody to see it and pray that maybe another one's coming like it.
That'd be nice.
Okay, why do we call them meteors? It's a Greek word, meteoros, meaning high in the air. The root word, of course, is where we get our term meteorology from, tied up to the atmosphere. Because in the old days, that's what they thought for a long time, that meteors were some type of atmospheric phenomenon like ball lightning or electronic discharges between particles in the atmosphere. They thought it was all within the Earth's atmosphere. It wasn't until the 19th century when folks began to realize that, hey, these puppies are coming into the atmosphere from deep space. But the name stuck. And meteors travel at speeds from a range up from a low of about 7 to 8 miles per second up to the maximum speed that they can be without getting kicked out of the solar system. 44 miles per second is the upper speed limit of the meteors that we see. So everything we see visually at night is going to go between 7 to 8 all the way up to 44 miles per second.
And you're saying if it's 45 miles per second, it leaves the solar system?
Kicked out of the solar system.
Because of the
called escape velocity.
force of
Yep. And interestingly enough, there is only one meteor shower, major meteor shower, that attains this magical upper limit of 44 miles per second, and that is the Leonids in November. Every Leonid we see, almost every Leonid we see, will be going 44 miles per second when we see it. Now, of course, the Leonids are famous for the 33-year cycle. We'll talk a little bit more about that in a minute. And of course, some particles, not all particles are that, I said most, are that size of a grain of sand or a speck of dust. Some are larger, and they are produce what we call the fireballs that turn night into day, that turn people green. You know, wherever you're at gets lit up in green light. Bright as the moon, bright as the sun, bright enough to be seen in daylight. Several years ago, 2016, there was right here in St. Augustine, about 10 o'clock on a Sunday morning, a daylight fireball went by and a lot of people saw it. Not me, I didn't see it. And some folks got the trajectory down, plotted where it went out to the Ocala National Forest and found pieces of the meteorite that was caused by that fireball. Right here, right in our own county almost. Okay, then, classic image of a fireball. This would be, okay, this was a famous picture taken during the 1966 Leonid meteor storm when rained, I estimated 500,000 an hour. What they were doing in the southwest U.S. where they had it clear, it was clear here too. We hear Dr. Mike Reynolds saw it, Patricia Rogers saw it, a couple of members in our early club saw it. Out there in Arizona, clear night, 5 o'clock in the morning, they were looking up, closing their eyes for 1 second, opening them again, and judging the number of meteors they saw in that 1 second their eyes were open. And by projecting that forward, they came up with 500,000 an hour. That complete sky raining Leonids in every direction it went on for over half an hour. It was visible partly in Florida. We didn't get thousands per hour, but I think there were 300 to 400 to 500 an hour seen here in Florida. And it was clear everywhere too. When did that ever happen? Nope. When you have that number of meteors, you're going to get some that are fireballs, and this is the classic example of the fireball caused by a larger particle. Most of them, not necessarily all, but about 99%, end in a terminal burst. Because the particle's larger, it's penetrating deeper into the atmosphere, finally it breaks up. Most, when you watch these movies, you see these meteors coming, shooting in and crashing into the ground straight. That's not really the way they do it. They come down into the atmosphere to a certain height, become so unstable that they burst, and the particles come down like rain. But this act of a terminal burst has a name. It is called a bolide, B-O-L-I-D-E. So most of the bright fireballs that we'll see, and believe me, back when we used to have star parties, we were seeing, when we could have star parties, we were seeing fireballs pretty well. I'd say maybe 1 out of every 1, 2, or 3 star parties, we would catch amazing fire. Mike, do you remember that one in the Kansas Inlet?
Yeah.
Lit you up green, baby.
Hell yeah. I was looking over Paul's shoulder. We were sitting across the table talking to each other, and all of a sudden here come a slow one going down toward the horizon, and Paul looked at me and realized what it was just by seeing I was suddenly green.
I had time to see it bounce off Mike, whip myself around, and see it burst in that terminal burst of the bolide. So they're amazing. I mean, they turn night into day, cast shadows. It's amazing. You can go through people's houses sometimes.
Okay. That'd almost be worth the cost to have a meteor come through your house and land in your living room all warm and smoky.
Oh, yeah, one lady's bedroom.
Yeah, sure.
Put it on auction.
I threw this slide in, I call it the 3M terms for meteors, because Hollywood and the movie industry gets it butchered so bad, it's not even close. Meteoroid, R-O-I-D, is the particle while it's still in planetary space before it enters the Earth's atmosphere. Meteor, just the word, meteor, is that particle while it's in the Earth's atmosphere. And this is another thing I like to tell people at the public outreach events that blows their minds. Most of those meteors that we see at night begin to burn up about 19 miles up in the atmosphere, way on the fringes of the Earth's atmosphere, and are completely burned out, most of them by 40 miles up. So in less than 1 second, they travel 50 miles. In the case of the really super fast ones. Pretty amazing. And then finally, those ones that do penetrate the entire run through the atmosphere and actually strike the ground are meteorites. Pretty easy to tell the three apart, but Hollywood butchers it when you watch these movies. I mean, they really ought to do some research. Okay. How often do they happen? All the time, constantly, 24/7, 365, morning, noon, night, day, you name it, all the time. But only the super bright ones are visible during daylight hours, like the one I mentioned that went across St. Augustine's skies at 10 o'clock on a Sunday morning. Most are very faint and require dark skies to see them, which ties back to where is the best place to see them, the darkest skies you can get. Unobstructed by trees, unobstructed by buildings, and unobstructed by artificial lights. The overall average, if you take every single night of the year, daytime, everything into consideration, the overall average is about 7 per hour. But that varies quite a bit, and I'll talk about that in a minute. And most of those are what we call background or sporadic meteors. The sporadic meteors are ones that are not associated with a known comet or a known asteroid. We'll talk a little bit more about that. And that gets into the real fun for me, and hope to me in the meteor watching was learning the differences. The number visible increases greatly after midnight. Another inherent problem with meteor observing is that the longer you go, the more you see. That overall average of 7 per hour could be 2 at 9 or 10 o'clock at night, increasing to 12 to 15 just before dawn, without a meteor shower around. Of course, with a meteor shower, that number multiplies. And as it said, meteor showers multiply the number of them seen, sometimes in a most spectacular way. Threw this in one more after midnight. Imagine that we are out on a spaceship 50,000 miles above the North Pole. Turn around and look right back at the Earth, going around. And also rotation, revolution. Earth going from left to right. We encounter the particles. We're going this way, which would be counterclockwise, rotating. Sunset. A couple of meteors hitting because we are on the back door of our direction. We're actually going the opposite direction, but we're looking out the back door. The analogy is when you're driving a car in a rainstorm, you look out the windshield pelted with rain. But you look out the back window, hardly any of it's almost dry. Nothing's hitting that back window. That's why we see very few back here. But as we crank around and we get close to midnight, this is midnight right here, then we go into the morning and we face the direction we're going and we start picking up that windshield effect of meteors starting to hit much more frequently. Any of that make any sense?
Yeah.
Okay. Of course, the best time, and in fact the only time I ever meteor watch anymore, I used to do it away from meteor showers, but now they're the best time. That's when you're going to see the most. Why waste time when you got to be up at 2, 3 in the morning? Best time to look. Happening at the same times year in and year out. Just write it down on the calendar. It's going to happen. All caused by comets, except the Geminis, which they don't know what that object is. 3200 Phaethon it's called. Could be a comet, could be an asteroid, could be both. And the meteor showers are named after the constellation where the radiant lies. That's why we come up with Geminids, they're in Gemini, Leonids in Leo, Perseids in Perseus. And that's how you can tell where the meteors are coming from, because the radiant point, which I'll talk about in a minute. Radiants are amazing the way they work. And meteor showers are able to produce up to 120 per hour, which is about 2 a minute or more. When the Leonid storm, it could be thousands per hour or dozens per minute. Okay. David Letterman had his top 10. I had to go in the top 10. The meteor shower top 10. These are the best. Their names, shower names, the dates in which they occur. Meteor showers don't happen in one night and they're over. Check these out. Quadrantids in January go from the 28th of December to the 12th of January. Maximum around the 3rd of January. And when I give this to non-astronomy folks, people are writing all this down, they're trying to keep track of everything. It's pretty amazing. If you look real close, the next one on our chart Delta Aquarians start around the 12th of July. Hello. Go to the 23rd of August, maximum on the 30th of July. That's our next target for a meteor shower to look at later this month. The new moon's on the 17th, so 2 or 3 nights after that, start looking for the Delta Aquarians. I love them. They're an amazing shower. 20, 25 an hour. Beautiful purple meteors. One of a couple of the purplest meteors I've seen were Southern Delta Aquarians. It just blows me away. And of course, leading up to the Perseids, the big one, 15 July to 24 August, maximum around the 12th of August. I say around because the Perseids have been throwing scientists for a loop in the last few years. They have not been doing what they're supposed to be doing. They are bad. People are out at the normal times looking for what they thought would be a great shower, and it's not, and then 2 nights later it does it when no one was out looking.
Like I think this last year there was an outburst.
There was a
And it was
magnificent
late.
outburst. I didn't see it because I was in the Keys, and guess what? Tropical Storm Fred was going over. And I don't think you guys got it clear up here either, did you? 300, you did? Did you see it, Randy?
Yeah, we, well, all of us did the Hannah Park night did because it ended up being the Hannah Park outreach night in August, and we got lucky. And we just happened to be out there, and it was just,
So you got to see that outburst?
Wow, that must have been cool.
Wow.
well, I think all of us did.
Cool.
We just got lucky.
And it was totally unpredicted. So again, for meteor showers, because they're unpredictable, you don't want to get out on just one night. Oh, it's supposed to be the 12th. Well, this year maybe it's not. Maybe it's the next night or the next. So I like to block about 4, 2 on either side, to see if it's going to be early, or it's going to be late, or it's going to be right on time. It makes a big difference. And then the rest of the year, beyond the Perseids, the Orionids in October, around the 21st, new moon. Yes! Taurids, very interesting. I think they're near full moon, but they go on for a long time. Big one is the Leonids, 17 November. I think it's first quarter moon. They are very cyclic, 33-year cycle. When the comet returns, there's a big chunk of particles called behind the comet. The last spectacular period for them was 1998 to 2002. Next one, 2032, 2033, 7, 8 years from now. Get close, folks. Could be in the storm cycle for the Leonids in less than 10 years. Highly recommend checking that out. Because again, like the Perseids, they don't always do what science predicts them to do. And that's one of the things I love about meteor watching, is the unpredictability of it. And-
Weren't we having trouble last year debating between what was a Taurid, a Leonid, and a Gemini, because they're kind of all just there?
Yeah. July starts what we call meteor season. It's where the most of the major meteor showers hit, and the overall meteor activity increases because we are going around kind of like getting into a better position for the Earth to be positioned so that we can see meteors more commonly and more frequently. So July to December, meteor season. And of course the Geminids, big star of the show, I think they're favorable this year. I don't know if it's new moon, but they're nearby, around the 13th of December. Perseids and the Geminids are the 2 best. That's why I put them in red. But then the Ursids, interesting little meteor shower, ends the year on the 22nd of December. And then the next week after that, start the next year, quads, and I think the quads are in favorable this year, 2024. So as you can see, they're displaced throughout the year. It's pretty cool. There's 10 good shots at seeing a decent meteor shower. Yeah, the full moon's going to take some of them, but it won't take all of them. The Delta Aquarians and the Perseids, you get one or the other every year. They're 2 weeks apart. Guaranteed, one every year, one or the other. And the Perseids last so long that we will see many of them during the watches for the Delta Aquarius. By 3, 4 a.m. in the morning, there'll be 20 Perseids an hour popping through, even though it's nowhere near the maximum. Okay, go ahead. A little bit of the dynamics, the celestial mechanics of it. Sun in the middle, Earth going around every year. We're not hitting, this is for the, I think this was the Perseids, yeah. February, we're nowhere near them. May, we're sort of near them, but not quite. Come around here in August, boom, we collide with the track that the comet, which is called Swift-Tuttle, and our orbit intersect, and the meteors start flowing in from that contact. Then we get out of it, November we're out, and the cycle begins. Every year around the 13th of August. Okay? Explanation of a radiant. I love this. This is Jane. Jane, this is you.
Oh, who is it now?
You may not have recognized her, but that's Jane.
I'm just begging for some.
Jane is out in the middle of the fairgrounds looking at a meteor shower. What the meteors are doing above her head is they're coming in parallel lines, just like lines on a piece of paper. But through the well-known visual perspective of parallel lines appearing to disappear to a point in the distance, this is what Jane is going to see. Going out, radiating away from a point called the radiance. And the effect, you can test this out, go to the railroad tracks, get your head down real close. See the pair of the railroad tracks disappear to a point in the distance. Meteor showers work on the same effect. Now that radiant will shift slightly through diurnal motion, slightly different position of the Earth 24 hours later. But for the most part, they will stay right within that boundary of that constellation where the radiant lies. And for the Perseids coming up, that point is almost dead on top of the doubles cluster between Perseus and Cassiopeia. That's why most of the meteors are shooting down the Milky Way from the Perseids. Okay. Another quick kind of visual. This is around the August 12th, 11 o'clock at night. Perseus rising in the northeast. Perseid radiant point. This is Cassiopeia, double cluster is right there. You would face east or northeast in this situation because that's the direction where the radiant lies at 11 p.m. But as the Earth rotates around, that radiant rises. At 5 a.m., the Perseid radiant is very high in the sky. So in that case, you're seeing, I saw this once from the Perseids in 1977. They were raining around the horizon. I was doing this. And seeing meteors in every direction. It was amazing. So the time of night that you're observing has a lot to do with it. But you tend to look in the direction of your darkest sky or in the direction of the direction that the radiant is. Like if it's rising in the east, you want to face northeast or southeast. If it's setting in the west, northwest or southwest or northwest. If it's dead overhead, face your darkest sky, wherever it is. Usually for us it's south, because we're north of Jacksonville. I mean, we're south of Jacksonville, so we got to worry about Jacksonville light. Usually facing south during the Perseid maximum at 5 a.m. is the best time to see it. Okay. Meteor watching, the basics. I love it because it's just your eyes. No telescope is required. Cheap. Budget astronomy. Binoculars can be used to enhance viewing pleasure. And in the case of the Leonids, when the storm goes on, saw this in 1998, you can follow the trains from the fireballs with binoculars. Watch them twist in the upper atmosphere. Go snake-like. That night, my late wife and I were still in Sicily. all I remember was the sky looking like a giant tic-tac-toe board with streaks of smoke trails going all the way around. It was crazy. Dark sky sights are the best. Comfortable reclining chair. A lot of folks don't do this. They'll come with no chair at all. Are you ready to stand up and break your neck for 3 hours? Highly recommend you go down to Ace Hardware or Target or Walmart and get a zero gravity lounge chair, zero G lounger.
Costco has them too.
They used to be about $40. What they are now, I have no idea. I haven't bought one in a few years, but they recline. They're so comfortable. The trick is going to be to stay awake at that point. But you will not have a stiff neck. You will be glad you had that relaxation to recline. And Mary, right?
Absolutely.
Yep. Try to get away from city lights, buildings, and trees. These are our 3 worst enemies right there in a quick sentence. City lights, buildings, trees, and clouds.
Number one.
Yes. The most enjoyable time is during the top 10 meteor showers. Try to avoid full moon. New moon is the best. First thing every year, I get a calendar. Where's the new moon's hitting? Where do the meteor showers hit in relation to that new moon? Oh, this one's good. Oh, no, not that one. Oh, this one's good. And it varies every year. This year is a good year because we have Perseids, Geminids, Orionids, and Leonids, and the April Lyrids were favorable too. Got out briefly for them. So it's a give or a take. Okay. I threw this in. One of the things I love about meteor observing is that it teaches you observing skills. You can learn the difference in magnitudes by seeing how the different meteors' brightnesses appear on the sky and judging them against known stars. And this goes through a few of them. You see one as bright as the sun, that's about -27, okay? Sirius is the brightest nighttime star at about -1.5. Canopus Vega is a 0 magnitude. Spica is a +1. Can't quite see that word, but that star is a 2, and so forth. So after a while, you kind of get to learn the nuances of, oh, that was the first magnitude meteor. Oh, that was the second. That was the fourth. When they get super bright up into this minus range, it gets really cute. We're judging them against Venus, which gets up to be almost -5. A quarter moon is about -6, roughly. A full moon is -12, approximately. The lower the number, the brighter the object.
It's
So
Polaris.
this is what-
I think that's Polaris.
Polaris.
Yeah.
Yeah, Polaris is a 2, yes.
Mhm.
Just below 2, 1.99, and slightly variable, but yeah. But the ones that are up here in the bright range, interesting to say. You can get 10 people see the same fireball. One will say -4. I think it was -8. No, -12.
Yeah.
You know,
Where's Jupiter in that?
Jupiter would be -2, which would be right about there. Venus would be a little bit beyond. It might almost -5. Right now, I noticed Venus last night was shining like a beacon.
I think
Anybody seen
tonight
Venus
is
lately?
its
Billy,
brightest.
probably.
Yeah.
Man, I mean, it must be near the conjunction that is close to the Earth, because it's blazing.
It and the moon are in its closest point to the Earth right now.
And that's only -5. I mean, we see a -12 and beyond. I mean, they turn night into day, sometimes. But that's a really cool thing to learn, kind of get a feel for in your observing skills as an amateur. Kind of get a feeling for the different, and each magnitude is 2.5 times in energy output. A 2 is 2.5 times more energy than a 3. Now 1 is 2.5 times more than a 2. And the way you figure it is that the difference between a +1 and a +6, which is about what most normal eyes are capable of seeing, is a difference in energy output of 100 times, 2.5 times, 2.5 times, 2.5, 6 times, gives you a difference between 1 and 6 of about 100 times in brightness. Pretty amazing. And then this is really cool stuff down here. Give you an idea. A 10 magnitude difference is 10,000 times in energy output for brightness. Hard to wrap your mind around. Okay. Upcoming major meteor showers. This was from last year. Update this one. I'm mad at myself. But let's talk about the Perseids for a minute. The classic historical maximum of the Perseids is the 12th of August, up until the last 4 or 5 years. Now it can be anywhere between the 12th of August and about the 14th of August, so it's like about a 3 or 4 night stretch there where that pop outburst could happen. We saw one a couple years ago at the fairground, 2020, maybe it was a COVID year, 2020 or 2021. It was the moon, full moon, new moon. We were there at like 10 o'clock at night. Those of us who were still left at 4 o'clock in the morning saw the light switch turn off. The Perseids had been really weak and sluggish, and we were falling asleep, and we were bad-mouthing them and moaning and groaning that nothing was happening.
You were the Debbie Downer.
I was.
Let's get it right.
I'm like, where are they?
You were
They're
the one
supposed to
sitting
be
there
here.
going, it's dripping like a faucet. Somebody turn the faucet on.
Somebody finally turned on the faucet, and they started popping left and right, fireballs over here. It was absolutely spectacular.
That's because half the people left there.
Yes, we had a lot of aperture sacrifice.
We did, yes, we did. We had some, and it took that. But so that's why, any meteor shower, all of these, including Perseids, 1, 2, 3, 4, 5, of the ones that are hitting from now until the end of the year, every one of them are best at between 4 and 5 a.m. in the morning. I'm sorry, guys.
Yeah, that's showtime.
That's showtime. Absolutely. And even if it should be sooner than that, sometimes the shower does not cooperate and will make us wait. So patience is a virtue, but darn well guaranteed that if any one of those 5 meteor showers is still well, Geminids are an exception. Okay? Geminids will be good at 10 o'clock at night because the radiant is much higher. The way the meteors hit the atmosphere makes them a whole lot more visible earlier in the evening. The best time to see the Perseids, the Geminids, is between 10 p.m. and 2 a.m. After that, they begin to actually go downhill.
Well, and we figured out the best time for the sky at the fairgrounds is 1 a.m. Like it just magically just becomes very clear at 1 a.m. We've still never figured that out.
I know. Well, if it were the summer, definitely that
Yeah.
would happen.
It's just like
But
this
in
magic.
December,
Yeah.
you can't always count on that 1 a.m. clear up. Last year was a classic example. It was just wiped out from one end to the other, several nights in a row, solid overcast. But one of these years, it's not going to be. The last time I saw the Geminids well was 2020, COVID year. COVID year wasn't good for a lot of things, but it was darn good for astronomy, let me tell you.
Wasn't that the one we saw the rocket launch?
And the rocket launch, yeah. We saw the Geminids. I was down in Southwest Florida, and they were doing almost 200 an hour. Clear at 3 o'clock in the morning, 2, 3 o'clock in the morning. I saw them raining into the Gulf of Mexico. I'm like, this is out insane. So one of these years we'll get them clear. And if you're really interested, the Ursids, interesting shower, but not for everybody. Okay, a few pretty pictures showing the radiant effect. Radiance here in the middle. See how a lot of them will tend to shoot around and go down the Milky Way? Love the Perseids. Okay. The Orionids, really nice picture taken from Mongolia. The radiant for the Orionids is way up in the outstretched arm of Orion, so see a lot of these puppies shooting down through Orion and down the Milky Way there again. Awesome show. I love the Orion. Okay. This was cool, saw it on the internet. A meteor from the ISS. Shooting through the atmosphere beneath them, looking down to see a meteor. Pretty cool.
What's the bright star-looking thing beyond
This
that?
right here?
Yes.
That's a
Is that-
UFO.
That's a UFO, okay. Okay, I'm glad to know that.
That's the only answer I can give. These are stars, no doubt.
Yeah.
That might be a star.
Maybe a star through the atmosphere.
I like UFO better.
Okay. Woo.
Oh, I love this one. This was on our Gemini watch. We were all
Yes,
out at
yes, it was.
the 21, I think, 2021.
It was chilly.
The moon set about 3, so we started at 3 a.m. It was solid clouds at 2:45 a.m. At 3 o'clock it was perfectly clear. It remained clear for 2 hours, and at 5 a.m. the clouds came and sucked over the sky again. We had 2 hours of seeing the Gemini
It was
maximum.
great.
And we all snuck out at 5 a.m. and went, we removed the construction sign. And then put it back. So all
Then
the
there
cars
was,
could get out.
2018, the experience that we had, the club had in 2018 was even more bizarre. It had been cloudy all night. We had a big group, probably even more than that. Solid clouds, we were twiddling our thumbs. Everybody decided to leave. I started to leave. That's how bad it was. I'd be out there all night even if it's cloudy, right? But I gave up. As I was pulling out of the parking lot, a gal was pulling in. She said, I was at the hockey game in Jacksonville. I just got out. I thought I'd come down and see what's going on. I said, I'm sorry. It's hopeless. We've been here for hours and it's not clearing up. I'm going home. She said, well, I just got here. I'm staying. 15 minutes that it took me to get to my house, I get a text from her. You better come back down. The sky is clear. We've seen 50 Geminids in 10 minutes.
Oh my God.
Turned right around, roared back to Matanzas Inlet, and had an unbelievable performance from the Geminids. They were doing 10 a minute for a while.
On this night, you were so trying to capture a meteor
Oh, on
with your
film?
camera. You were, you know,
I remember.
you were
That's right.
channeling Robert.
The worst part was his camera was always pointed the wrong direction every single time.
The meteor was over there. Oh, I better turn over there. Oh, now the meteor's over here.
We started naming his camera Dennis.
I just don't have the blonde, folks. I've given up. Okay, I think that's information, no problem. All right, thank you guys. That's all I have. Questions?
I've got a question. Why don't you know, with the other meteor showers, you know what comet it is or what asteroid it is, but the Geminids you don't, and why not?
Well, it's a question. It's always a question of math. Figuring orbital dynamics, orbital characteristics. In most of, other than the Geminids, in most of the other major meteor showers, science was able to make a quick and immediate correlation between the mathematics of the orbit of the meteors corresponding beautifully to the orbit of a known comet. So the link was, the first one was made by Edmund Halley of Halley's Comet fame. He was the first one to connect the Perseid meteor shower to Swift-Tuttle, the comet. But in the case of the Geminids, there wasn't a comet there. It was like, holy smoke, is this a meteor shower not even produced by anything? What's going on? And finally, years later, somebody discovered the asteroid. And then it became, wait a minute, an asteroid's not a comet. What's going on here? We're dripping.
Oh, yeah.
So the last I've read was an article that said that they are now leaning to the possibility that it may be both. There may be a comet and an asteroid traveling close together, and makes it a true hybrid meteor shower between a comet produced and a hybrid produced, but there's still a lot of uncertainty about that, and scientists are still trying to figure it out. But in my opinion, whatever it is that causes it, keep causing it.
It's a mystery.
Yep. And the other thing I didn't mention too much on this particular program was the possibility of a previously unknown meteor source suddenly kicking up because we are encountering the orbit of a comet that is not, most of the comets that produce meteor showers are what we call short period comets. Comets that have complete orbits in and around the sun, out to where they're going and back in less than 200 years. That's the cutoff. Anything above 200 years is not periodic, anything below. But that doesn't mean we could cross the orbit of a non-periodic comet unexpectedly, or have one suddenly flare up, as we saw last year when we were out for the Tau Hercules. That was a meteor shower that occasionally in past history had put on a good display and then disappeared for decades. Nobody saw it, gave up on it. Guess what? It didn't care. It came back anyway. And we had a real good night that night. It wasn't perfectly clear, but we saw about 100 an hour. It wasn't anything like they were hoping. They were predicting maybe thousands. But it was still a pretty doggone impressive show. And I love meteor observing because it's a chance for us to get together as a group, see something together, and have a darn good time while we're doing it.
And everybody's together on it. You know, we're all looking at the same thing.
That's right. That's right.
Only sucks is when they're short-lived and you're like, wait, it's right. Never mind.
Yeah, I wish we could get them to last longer.
The
But
Delta Aquarids, I think, are the long-lasting ones.
The which one?
Delta
Delta.
Aquarids.
The Delta
Are the
Aquarids.
ones that.
They tend to last a little bit longer.
Them and the Taurids, I think, are the two.
And that's the one coming up around later this month. So we'll be, if it's clear, scheduling some watches. They will be after midnight, I'll tell you now. That's the time you gotta do it, but they're fun. Now, the ones that I said were like 7 to 8 miles per second, the real super slow guys, those are the ones that you can sometimes see cross the entire sky and could be in sight for 10, maybe 15 seconds sometimes. They're not common, but they do happen. And those have a name. They're called earth grazers. Yes, ma'am. That word, earth grazers. An earth grazer is an example of a meteor particle. Imagine the earth. The angle that the particle is intersecting the earth is so steep or shallow that it is actually bouncing in and out of the edges of the Earth's atmosphere. Like you'd throw a flat rock across a pond or a lake and see it. Same thing. I've seen quite a few of those. The Geminids are very good at that. Mary, Mike, and I were out at Fairgrounds one early evening, clear. How did that happen? And we were able to see several very long, slow Geminids go tracking through almost the entire sky. So that's cool, and learning when to get out to see those. Saw them for the Perseids when Neil Brown, bless his soul, and I were out early evening at the Matanzas Inlet. And that was one of the few times in my life that I've ever seen a pink meteor. A couple of the Perseids we saw were pink. Pink as an azalea. I mean, it was amazing. So, something to keep in mind. I see our weather's turning outside. Look at that. All right, well, if no others, thank you very much. Appreciate it.
I'm going to turn the meeting right when the storm's at its worst point.
Yeah, really. Look, it's storming.
Yes.
Not meteor storm.
Honor of us.
Meteor storms. Those things are unbelievable. I've been lucky enough to see 2 in my life. 3. I've seen 3. 1999, 2001, and 2002 for the Leonids. pray that we can get another study. Science is all up and down about that too. That every time it happens, scientists get together and they say, well, that's the last time it's ever going to happen. We're not going to see it at the next 33-year cycle. Well, let them say it, baby, because they said it in 1933. There's not going to be anything in 1966. It's not going to happen. That was the spectacular storm that lit up everything. They don't have a clue. That's why, meteor watching is good for amateurs, because we're the eyes. We go out there and see. Professionals are, looking on computer screens in a computer room somewhere. Even nowadays, the big rage is cameras for all-sky meteor surveillance. They've got it down to a point where they can track meteors and do major axes and eccentricities of orbits and the whole 9 yards. But they don't tell you how many there were. They don't see the whole sky. They only see sections about 30 degrees. Fascinating thing to get into, but it's not like visual meteor observing. The only thing that's like visual meteor observing is visual meteor observing.
It's almost as interesting as meteors is watching Paul count meteors.
Yeah.
Like there could be 3 different meteor showers going on, and he'll track them each one separately. He'll have 3 running numbers going.
I've tracked up to 7.
Up to 7. Okay.
Jeez.
7.
Talk about brain damage.
Well, I've seen you do 3.
Yeah, me too.
And then you're like, wait, was that a delta aquarid or was that a...
And then is it? Oh, it's a sporadic. Okay.
Yeah, because his favorite is the sporadics.
And this period coming up in late July, I pray we'll have some clear nights, because it's such an interesting time. You've got the Delta Aquarians from 2 different radiants. You've got the Alpha Capricornids, which are extremely slow-moving meteors. The Delta Aquarians are medium, and you've got the Perseids shooting through it fast. You've got the whole spectrum and range visible at the same time. And they're all coming from different parts of the sky. It's fascinating.
And he feeds the data to
To the American Meteor Society and the International Meteor Organization. And then they will do computations based on worldwide observers, not just any one person or any one group in one place on Earth, but they'll combine Japanese with Europe, with Middle East, with South America, with Florida, and come up with a total Earth view of what that meteor shower did that particular year and when it did it. And you can go online, imo.com, and they have the real time is feeding. You can see the spikes or the dips.
One time I said to him, Paul Jones, I challenge you to spend 3 minutes watching the meteors and not counting them,